So hello everyone. We will discuss today the 10-marker question that came in this year's mathematics paper. The topic is uniform convergence. The question was very easy. The question is asking you test the uniform convergence of the given series. Okay, so we will discuss the two methods from which this 10-marker can be done. Okay, so let's start with the traditional method. Okay, that is your method one. So if you see this, if I write the series as sigma f of nx. So f of nx is equals to x to the power 4 upon 1 plus x to the power 4 to the power n minus 1. Okay, n minus 1. So this is the fn. This is your fn. So this can be written as this. Okay. So if I manipulate it a little bit, x to the power 4 plus 1 minus 1 whole upon 1 plus x to the power 4 n minus 1. Okay, this can be written as 1 plus x to the power 4 upon 1 plus x to the power 4 n minus 1 minus, okay, 1 upon 1 plus x to the power 4 n minus 1, right? Okay. So this can be written as sigma 1 upon 1 plus x to the power 4 n minus 2 minus 1 upon 1 plus x to the power 4 n minus 1. If you see, this is a series of differences where each term will cancel out with the previous term. Okay, so therefore sigma fnx will come out to be, if you see, if I put n equal to, let's start with 2. If I put n equal to 2, then it will be 1. Okay, 1 minus 1 upon 1 plus x to the power 4. Okay, this is the first term, plus 1 by x, 1 plus x to the power 4 minus 1 plus x to the power 4 square. Okay, and this will go on like this, plus 1 upon 1 plus x to the power 4 n minus 2 minus 1 upon 1 plus x to the power 4 n minus 1. Okay, so this is the thing. So if you see, this term will cancel out with this term will cancel out with some term here, and this term, all these terms will cancel out. You will be left with only two terms, which will be 1 minus 1 upon 1 plus x to the power 4 n minus 1. Okay, now let's check the pointwise convergence. Okay, pointwise convergence. Okay, at every point, limit n tends to infinity, sigma of fnx is equals to limit n tends to infinity 1 minus 1 by 1 plus x to the power 4 n minus 1. X to the power 4 is a positive term for all x between 0 to 1, and it is 1 plus, so it is greater than 1. So this will be 1 to the power infinity, 1 by infinity will become 0, so answer will be 1. Okay, answer will be 1. Okay, this is the case. Now let's check the uniform convergence. Uniform convergence. Okay, uniform convergence. For uniform convergence, if you see, okay, one more thing actually before checking this. Okay, this is true for all x not equal to 0. Okay, now when x equals to 0, sigma fnx becomes 1 minus 1 is equals to 0. Okay, so you can say that sx, which is equals to limit of sigma fnx, is equals to 0 when x equals to 0, and 1 when x is not equal to 0. Okay, not equal to 0. From here we can use two things. Okay, so here your method 1. What is the method 1? You can directly say, because the limit function, the function that the pointwise convergence is happening, is not a continuous function. At x equal to 0, this function is not continuous. You can see this function is not continuous. Every uniform convergent series of functions will converge to a function which is continuous. The converse need not be true, but this is if a series is converging uniformly, then the function that is obtained will be continuous. So you can directly say that as limit point function is not continuous at x equals to 0, therefore series does not converge uniformly for x equals to 0. So in the interval 0 to 1, it is not uniformly convergence. Okay. Now, what is the traditional method? That is your method 2. Method 2. So you will write sigma fnx minus sx should be less than equal to epsilon. Okay. For some n greater than equal to m, we have to find such n and m. Okay. So here, what was sigma fnx? 1 minus 1 upon 1 plus x to the power 4 to the power n minus 1, and sx was minus 1, right? Should be less than epsilon. Okay. Now, this will be mod 1 upon 1 plus x to the power 4 and minus 1 should be less than epsilon. Okay. Now, if I write it 1 plus x to the power 4 and minus 1 should be greater than epsilon, because I took the inverse, so inequality sign will change. Okay. Now take log n minus 1 ln of 1 plus x to the power 4 is greater than ln e. Okay, because log is an increasing function. Okay, ln x is an increasing function, so you can so this inequality will hold even after taking log. So from here, n minus 1 is greater than ln epsilon upon ln of 1 plus x to the power 4, right? So n should be greater than 1 plus ln epsilon upon ln 1 plus x to the power 4. Wait. Okay, 1 plus ln epsilon upon 1 plus x to the power 4. Okay, ln x to the power 4. Okay, one is separate. Now, there are two cases here. If x is not equal to 0, then you can find m is equals to 1 plus ln epsilon upon ln 1 plus x to the power 4. And then in that case, for all n greater than equal to m, okay, sigma fnx minus sx will be less than epsilon. So from 0 not included to 1 included, this is uniformly convergence. Okay, this is UC. Okay, now let's check at x equal to 0. At x equals to 0, n greater than 1 plus ln epsilon upon ln of 1. Ln of 1 is 0. So n should be greater than infinity, which is not possible. Okay, so at x equals to 0, no m possible such that for all n greater than equal to m, sigma fnx minus sx is less than epsilon. Therefore, series is not UC at x equals to 0. So this was a very easy question. Okay, you can do by any method. You can, once you find the limit point function, you can directly say this is not because the limit point function is not continuous, therefore it is not uniformly convergent. And you can explain using the traditional definition of uniform convergence. Okay, have a good day. Next, we will discuss the Riemann integral question.